Okay, so if I know that the cosine of x is negative 1/4 and the tangent is positive, and I want to find all of the other 5 trig functions, I'm going to use my trig identities hexagon as a graphic organizer. So the tangent goes in the leftmost vertex, and then we use that quotient identity, so tangent equals the sine divided by the cosine. Then we use our reciprocal identities to get the other corners. So cosine's reciprocal is secant, sine's reciprocal is cosecant, tangent's reciprocal is cotangent. And then I'll switch colors here so we can keep track of what we know. And the cosine was given as negative 1/4. So right away I can put that 1 in the second and then do my reciprocal. So the reciprocal of cosine is secant, which means secant is the reciprocal of negative 1/4, which is negative 4. And then we can use a Pythagorean identity in order to find either the sine, if we did sine squared plus cosine squared equals 1, or since I want to avoid that fraction, I'm going to use the Pythagorean identity here to find the tangent, because tangent squared plus 1 is equal to secant squared. So if I substitute in my secant squared as a negative 4, then the tangent squared x is equal to negative 4, that quantity squared, and then I'll subtract that 1 over from the other side, and that's a minus 1. And then tangent squared x is equal to 16 minus 1, which is 15. We can square root both sides, and the tangent of x would be plus or minus square root of 15. But I know from up here that the tangent of x is positive, so I'm going to discard the negative option and just keep the positive square root of 15, which doesn't need to be reduced because 15 is just 5 times 3. Okay, so now I've got the tangent. That means I can do my reciprocal to get the cotangent, and the reciprocal of root 15 would be 1 over square root of 15, and then we need to rationalize that denominator. So we multiply the top and bottom by root 15 over root 15 and get root 15 over 15. And then we found the cotangent. Okay, to get the sine here, we could go ahead and do the product identity by making this hinge here. So the 2 vertices immediately to the right and the left, remember they make the product of the one in between. So that means that the sine of x is equal to the product of the tangent times the cosine. And then we'll substitute in root 15 for our tangent, negative 1/4 for the cosine, and then when we multiply those together, we get negative square root of 15 over 4. And that would be the sine value. Then the last one we need to find is the cosecant, and we could find that either by doing another product identity, or we could do a reciprocal identity with the sine. We could even, if we wanted to, we could do a quotient identity, because cosecant is cotangent divided by cosine, or cosecant is secant divided by tangent. Any of those would work. I think the multiplying with the product would probably be easiest in this case, so I'll go ahead and do cosecant of x is equal to the cotangent times the secant, and then we'll substitute root 15 over 15 for cotangent, negative 4 for the secant, and we'll have negative 4 root 15 over 15. And that would be my answer to all of the remaining trig values when we're given just the cosine of x equals negative 1/4 and the positive tangent. Hope that helps.